Welcome back to Sleepless Mysteries. On July 1st, 2025, astronomers spotted something that did not belong to our sun. A faint glowing traveler cutting across the sky, not born of our solar system, but of another star, another place far beyond our reach. They called it 3I Atlas, the third confirmed interstellar object to enter our neighborhood. A fragment of the unknown, slipping briefly into view before vanishing again into the abyss. At first, it seemed like another comet. Dust, ice, a faint green tail, something we could model and measure. But then came the chemistry. Instead of neat patterns, familiar signatures, or predictable behavior, Atlas defied everything we thought we understood. Its gases were unusual, its brightness inconsistent, its orbit bending in ways that didn't follow simple rules. It carried compounds, cyanides, nickel, and traces of the unexpected that hinted at processes alien to our solar system. It was, in every sense, not of this world, and that is what makes it unsettling. Because comets should obey the same chemistry, no matter where they come from. Hydrogen, carbon, oxygen, frozen ices, and dust. That is the recipe we know, but Atlas does not fit. Its spectral lines glow with a story written in a different language. Its outgassing, its shifting brightness, even the speed at which it turns all point to a chemistry that does not behave as it should. To study it is to admit that the rules we trust may not apply everywhere. This is not the first time. Oumuamua, discovered in 2017, baffled scientists with its acceleration as if pushed by invisible hands. Borisov in 2019 carried water, but in unexpected abundance. Now Atlas joins them, not as another anomaly, but as another piece of a pattern. Visitors from other stars, each carrying secrets written in their very matter. What are they trying to show us? What truth lies in the chemistry of the alien? Ancient peoples once believed comets were omens, harbingers of change, divine messengers carrying warnings from the gods. And perhaps they were right to sense something uncanny. For when we look at Atlas, we are staring not at ice and dust, but at the physics of another star system, matter shaped by alien suns, forged in conditions no human has seen. To hold even a fragment of it would be to touch another world, another story of creation. You don't need to see the data charts or spectral graphs to follow this. Just let the words guide you. Close your eyes if you wish. Picture a glowing traveler cutting across the night sky, its tail shimmering in colors we cannot explain. Imagine astronomers staring at their instruments, their models failing, their certainty slipping. Imagine the awe and the unease of realizing that the universe still holds chemistry we cannot recreate. Before we begin, if you haven't already, subscribe to Sleepless Mysteries so these quiet journeys into the unknown will always find you. Tap the like button if stories like this fill you with wonder. And if you're still awake, share in the comments where in the world you are listening from and what time it is right now. Now, let the world soften. Above us, the alien comet moves. Its chemistry whispers of other suns, other worlds, other rules. And tonight, we listen to what it refuses to explain. This is 3I Atlas, why its alien chemistry defies all science, unsolved mysteries for sleep. And it begins now. The forbidden molecules. When 3I Atlas first swept into our solar system, astronomers thought they were witnessing another frozen relic from interstellar space, a visitor of ice, dust, and stone, like Oumuamua before it. But when telescopes began to study its chemical signature, something didn't add up. The molecules reflecting back from its tail and surface were not like anything found in comets that orbit our sun. They weren't even like the chemicals cataloged from deep space dust clouds. Instead, researchers saw strange compounds, combinations of atoms that looked more like laboratory products than natural substances. It was as though 3I Atlas carried forbidden molecules, structures that shouldn't have formed spontaneously in the vacuum of space. And yet, there they were, defying science. Spectrographic readings showed bonds between carbon, nitrogen, and hydrogen in unusual geometries. Not the simple methane, ammonia, or cyanide one might expect, but elongated chains and cross-linked frameworks. Some of these resembled what chemists call metastable compounds, fragile constructions that can exist for short periods in controlled environments, but usually collapse in nature. And yet here they seemed abundant, stable, and strangely persistent under solar radiation. It was as if 3I Atlas had preserved them intentionally, as if it were a vault carrying a recipe book of alien chemistry. The mystery deepened when infrared analysis suggested the presence of molecules whose absorption bands didn't match any terrestrial reference. In labs on Earth, scientists use spectroscopy to identify molecules with extreme precision. But the fingerprint from 3I Atlas yielded unknown patterns. Peaks and troughs in the light didn't match methane, didn't match ethane, didn't match formaldehyde or any other cataloged interstellar organic. It was as though someone had rearranged rules of chemistry itself, inventing new molecular alphabets never seen before. Some experts suggested this could be the result of long interstellar travel. Cosmic rays bombarding its surface for millions of years might have twisted simple molecules into exotic shapes. Radiation can do strange things, mutating, cross-linking, or rearranging atoms into forms not normally stable. But even this theory failed to explain the sheer concentration. Radiation damage usually creates chaos, fragments, broken bonds, instability. But in 3I Atlas, there seemed to be order, not chaos. The molecules weren't shattered, but carefully assembled, almost as if following a blueprint. That led some voices on the fringe of science to propose an unsettling possibility. Perhaps the chemistry of 3I Atlas was not natural at all. If another civilization had engineered it, crafted its chemical makeup the way humans design plastics or nanomaterials, it might explain the anomalies. Instead of being a random snowball, it could be a container, a delivery system, a vessel programmed to carry molecular codes across the galaxy. But why? And to whom? The comparison to panspermia quickly emerged. For centuries, thinkers have speculated that life on Earth may not have begun here, but arrived from space on comets and asteroids. What if 3I Atlas were proof of that theory taken further? Not just seeding the building blocks of life, but broadcasting advanced molecular systems that might awaken, replicate, or communicate under the right conditions. The forbidden molecules could be the seeds of something entirely alien. Structures that don't align with DNA or proteins as we know them, but represent an alternative path to life. Laboratory simulations tried to reproduce the conditions of 3I Atlas. Scientists exposed simple molecules to radiation, high pressure, and freezing cold. They produced strange results. Odd polymers, unstable radicals, exotic ices, but never quite what the object revealed. It was as though 3I Atlas had secrets Earth could not imitate. Even with the best supercomputers, the predicted spectra failed to match, which left a troubling thought. If these molecules can't be recreated naturally in labs, then how could they exist out there on their own, unless something or someone built them? The implications stretched further. Forbidden molecules could act as signals. Their chemical signatures might be intentionally designed to stand out, to tell any intelligent observer, this is not natural. Someone made this. Like a cosmic billboard, the oddities in its chemistry could function as a message encoded in matter itself. Unlike radio signals that vanish into the noise of space, molecules endure. They travel. They persist for millions of years, carrying a silent code. If 3 Atlas is such a message, it means the senders didn't want to talk across time. They wanted to talk across eternity. Skeptics argued for caution. Spectral analysis can be misinterpreted. Cosmic dust, telescope interference, even subtle calibration errors might create illusions of new molecules. But the same skeptics admitted one uncomfortable fact. The data had been cross-checked by different observatories, different instruments, across different wavelengths. The anomalies persisted, and some of the world's most experienced astrochemists admitted off record that they had never seen anything like it. Whispers circulated that government laboratories were analyzing intercepted fragments of dust trailing from 3I Atlas. If those samples proved the existence of forbidden molecules, the information would likely never be released in full. It would be classified at the highest levels, locked away until someone decided the world was ready. Because such a discovery wouldn't just change astronomy. It would change biology, chemistry, even philosophy. It would mean humanity is not the only intelligence capable of manipulating matter at the molecular scale. And so, 3 Atlas became a mirror for our fears and hopes. Were these forbidden molecules the remnants of alien technology? Were they seeds of life cast into the dark like cosmic spores? Or were they evidence of a universal chemistry that humans had yet to grasp? If the laws of nature allow molecules so strange, so unnatural to us, then perhaps our science is incomplete. Perhaps the cosmos holds not one chemistry, but many. Different toolkits for different worlds, different recipes for different kinds of life. The object continues its path, drifting farther from our reach with each passing day. We may never touch it, never hold a vial of its material in our hands, but its mystery lingers. Every spectrum, every anomaly reminds us that the universe still guards secrets deeper than our textbooks. The forbidden molecules of 3I Atlas may never be fully explained, but they have already served their purpose. They have reminded us that science is not finished, that the cosmos is stranger than we dream, and that somewhere, perhaps intelligence older and wiser may have written its story into the molecules of a wandering star. Carbon chains from beyond. When the first deep spectral scans of 3I Atlas arrived, the data hinted at something extraordinary. Instead of the usual cometary signature, simple molecules like water vapor, carbon monoxide, and methane, the readings suggested elongated carbon frameworks. These weren't the short, random chains expected from frozen interstellar debris. They were long, ordered sequences, branching in ways more reminiscent of synthetic polymers than natural ice-bound organics. To many, this became one of the most astonishing aspects of 3I Atlas. The discovery of carbon chains from beyond our world, structures so complex that their very existence challenges our understanding of chemistry. Carbon, of course, is the backbone of life on Earth. Its ability to bond in diverse geometries allows it to form sugars, proteins, fats, and DNA. But what astronomers saw in 3I Atlas did not neatly align with life as we know it. The molecular patterns showed chains far longer and more stable than anything typically produced in space. Interstellar radiation usually tears carbon bonds apart, leaving behind a soup of simple molecules or unstable fragments. Yet here, the chains were not just intact. They were abundant. They seemed to thrive in an environment where they should have been destroyed long ago. One theory proposed that 3I Atlas passed through regions of interstellar space rich in carbon clouds, where radiation sculpted the molecules into ever more complex forms. But such chains, once created, should have quickly degraded. The vacuum of space and the ceaseless bombardment of cosmic rays should have shredded them into dust. Their survival suggested something else. Either a protective environment inside the body of 3I Atlas or an unknown mechanism that continually rebuilt them. Neither explanation fit comfortably with current science. The chains themselves raised deeper questions. Some appeared to have alternating patterns, carbon atoms arranged in repeating sequences that hinted at functionality. On Earth, similar arrangements are often engineered. Humans create polymers for plastics, nylons, and advanced materials by carefully guiding how carbon atoms connect. Nature rarely makes these kinds of ordered sequences on its own. The idea that such polymers could arise naturally in space seemed improbable, and yet the telescope readings were clear. The carbon chains of 3I Atlas had a precision that was difficult to dismiss as coincidence. Astrobiologists pointed out a startling possibility. What if these chains were not just random chemistry, but precursors to alien biochemistry? On Earth, the earliest life forms relied on simple molecules that linked together into self-replicating structures. Could 3I Atlas be carrying its own recipe for life, encoded in chains that don't resemble our DNA but serve the same role? If life elsewhere took a different evolutionary path, its molecular scaffolds might look utterly alien to us, yet still serve as the foundation for replication, metabolism, and consciousness. These carbon chains might be, in effect, an alien form of genetic code. Another angle came from material science. The chains resembled nanostructures engineered in laboratories for high strength and conductivity. Carbon, when arranged in long, stable patterns, can create materials harder than steel, more conductive than copper, and lighter than plastic. If the chains in 3I Atlas had similar properties, then the object might not just be a natural comet. It could be a vessel, its chemistry part of its construction. Imagine an interstellar probe whose very body is made of self-healing radiation-resistant polymers woven at the molecular level. That would explain both the stability of the chains and their abundance. They weren't cargo, they were structure. The comet itself might be technology disguised as rock and ice. Skeptics, however, urged caution. They argued that spectrographic data is notoriously tricky to interpret. Overlapping signals, dust interference, or exotic ices could mimic the signature of long carbon chains. Perhaps these were nothing more than familiar molecules stretched into unusual states. But even they admitted a troubling fact. Multiple observatories across different wavelengths reported the same anomalies, and the patterns weren't chaotic, they were consistent. The carbon chains were real. If real, then what do they mean? Some scientists suggested they might be remnants of processes near dying stars. Carbon-rich stellar winds could forge unusual molecules, then eject them into space, where they accumulate in comets. Others thought of hydrothermal chemistry, similar to what occurs at Earth's deep-sea vents, taking place inside icy bodies with internal heating. In such environments, carbon chains could elongate, combine, and stabilize. Yet, no known astrophysical process could explain their quantity in 3I Atlas. It was as if this visitor carried more than the usual chemical baggage of space. It carried a design. The question of intent haunted the discussion. If these chains were natural, they represented a new branch of cosmic chemistry, one that could redefine how we understand the origins of life. But if they were engineered, the implications were far more staggering. It would mean we are not the first intelligence to use carbon's flexibility as a tool. Somewhere, perhaps millions of years ago, another mind had sculpted molecules as deliberately as humans sculpt machines. And now, one of their creations was passing through our solar system. Conspiracy theories flourished in the shadows of this discovery. Some claimed that governments had already collected dust from 3I Atlas, confirming that the chains were unlike anything in earthly labs. Others whispered that samples revealed not just chains, but traces of instructions embedded in the molecules, like barcodes written in carbon. The idea seemed far-fetched, yet the longer the mystery persisted, the harder it became to dismiss. After all, nature does write instructions in molecules. Our own DNA is proof of that. Could alien chemistry have found its own language in chains of carbon? Even without proof, the symbolism resonated deeply. For centuries, humanity has wondered if life elsewhere would look like ours. Would it have DNA, proteins, cells, or would it be something unrecognizable? The carbon chains of 3I Atlas hinted at the latter. Life may not need to mirror us to exist. It may write its stories in different codes, using the same universal building blocks, but arranging them in ways we cannot yet decipher. As the comet receded, the chance to study it closely slipped away. But the mystery remained. Astronomers continue to comb through the data, arguing over peaks and spectra while philosophers grapple with the bigger picture. If the carbon chains are natural, then the universe may be teeming with pathways to life, each as valid as DNA. If they are engineered, then we have just glimpsed the fingerprints of another intelligence, one that has mastered molecular design on a scale we cannot yet imagine. Either way, the message of 3I Atlas is clear. The cosmos is a library of chemistries, some familiar, others alien. And every once in a while, one of its books drifts into our skies, offering us a chance to read a page we never knew existed. The carbon chains from beyond are one such page. They whisper of life, of intelligence, of possibilities that stretch far beyond Earth. They challenge us to admit that science is not complete, that the universe holds more stories than we have yet learned to tell. And in their long, mysterious bonds, they may carry the greatest story of all, that we are not alone, and that the language of life is larger than we ever dreamed. Alien isotopes. When scientists turned their instruments toward 3I Atlas, they expected to see the usual fingerprints of cosmic matter, hydrogen, oxygen, carbon, and nitrogen in their standard isotopic ratios. These ratios act like barcodes, telling the story of where a substance was born. Stars, supernovae, and interstellar clouds each leave behind their own unique balance of isotopes, subtle variations in the numbers of protons and neutrons inside atomic nuclei. Earth's oceans, for instance, have a very specific ratio of hydrogen to deuterium. Martian rocks show another. By comparing these signatures, scientists can trace origins across the solar system and beyond. But when the data from 3 Atlas was analyzed, the isotopes didn't match anything familiar. Instead of the expected cosmic norms, they revealed imbalances so strange, they were immediately labeled anomalous. Ratios of hydrogen to deuterium were wildly off from the interstellar medium. Oxygen isotopes leaned toward distributions never seen in comets, planets, or stars. Even carbon carried peculiar ratios, as if it had been forged in a furnace unlike any known stellar environment. These alien isotopes became one of the most confounding mysteries of the object, suggesting it had an origin far outside the realm of normal astrophysics. To the average person, the difference between one isotope and another seems small, a single neutron more or less in the nucleus of an atom. But to scientists, those differences mean everything. They are the fingerprints of cosmic history. Every body in the solar system carries its own isotopic ID card. That 3I Atlas carried one that matched nothing else meant it was either unimaginably ancient, forged in conditions older than the galaxy itself, or it had been engineered. Both explanations were staggering. Some researchers speculated that 3I Atlas might have been born near a neutron star, where extreme conditions could twist isotopic ratios into bizarre patterns. Others suggested it could have formed in the remnants of a supernova, carrying material blasted out during an explosion that seeded heavy elements across the cosmos. But even those explanations had cracks. The ratios weren't random chaos, they showed consistency, as though arranged. A natural event should scatter isotopes unpredictably. Yet here, the distributions were steady, deliberate, almost purposeful. That raised a chilling question. Could 3I Atlas be artificial? If a civilization had mastered nuclear chemistry, it might use isotopes as markers, codes, or even fuel. On Earth, scientists enrich uranium by adjusting isotope ratios for use in reactors or weapons. What if 3I Atlas was carrying enriched material of its own? Its trail of alien isotopes might not be an accident, but a signal, or worse, evidence of advanced technology. Some whispered that the object could even be a power source, a vessel carrying isotopes designed to endure the void for millennia. Reports from infrared and radio observations suggested further anomalies. Certain isotopes of oxygen and nitrogen were overrepresented, ones rarely found in natural bodies. In laboratories, those isotopes are sometimes used in experiments because their unique properties make reactions easier to track. Was it possible that 3I Atlas carried them for a similar purpose? Was the comet itself an experiment cast into space to see how far such isotopic mixtures could travel, or how they would interact with planetary atmospheres? If so, humanity was not the intended audience, but we had stumbled upon the test anyway. Astrobiologists couldn't ignore the implications. Isotopic ratios are one way scientists on Earth search for life. Certain processes, like photosynthesis or metabolism, alter isotope balances in distinct ways. If 3I Atlas carried those imbalances, it might mean biological activity, or something that mimicked biology had touched it. Could an alien biosphere, long extinct, have imprinted its chemical signature into the body of this traveler? Or had an alien intelligence deliberately altered the ratios to broadcast a message? The idea of isotopes as communication might sound strange, but it fits a certain logic. Radio signals fade, laser beams scatter, but matter endures. A molecule enriched with specific isotopes could carry meaning across light years. It could survive eons in the void, delivering its message long after the civilization that sent it was gone. Some scientists quietly speculated that the isotopes in 3I Atlas were not errors of nature, but words in a cosmic language, ratios instead of letters, chemistry instead of ink. Of course, skeptics rushed to dismiss such ideas. They argued that isotopic anomalies might simply reflect how little we know about interstellar chemistry. The universe is vast, with billions of stars and environments we've never studied. Perhaps 3I Atlas was just an oddball, a product of a corner of the galaxy we haven't yet sampled. But even the skeptics admitted it was a troubling oddball. Its chemistry wasn't just unusual, it was outside prediction. And science does not sit easily with surprises it cannot model. Whispers circulated that classified laboratories were examining the data more closely than public science allowed. If 3I Atlas had truly delivered alien isotopes, the implications for energy, technology, even weaponry would be profound. The balance of power on Earth could shift overnight if new isotope manipulations were unlocked. That possibility, some argued, was reason enough for governments to keep the details hidden. Meanwhile, the public was left with scraps, hints of alien chemistry without the full story. Philosophers saw something deeper in the mystery. If isotopes carry the memory of their birthplaces, then 3I Atlas was a messenger from a realm beyond our comprehension. It was not just matter, it was history. Its atoms had lived through events unknown, perhaps in galaxies long extinguished. Holding such material in human hands would be like reading a chronicle written in the bones of stars older than Earth itself. Whether natural or artificial, the alien isotopes told a story far bigger than us. And then came the unsettling possibility that these isotopes were not just messages, but tools. On Earth, isotopes are used as tracers in medicine to map disease or deliver treatments. They are used in archaeology to track the diets of ancient peoples, in climate science to reconstruct past atmospheres. If humanity already uses isotopes as instruments of knowledge, might not another intelligence do the same? Could 3I Atlas be carrying isotopes as instruments for some grand cosmic experiment, one in which our solar system is just a data point? For now, we may never know. 3I Atlas is already retreating back into the dark, its secrets locked in ice and dust, but the memory of its alien isotopes remains. They remind us that the universe is not uniform, that the chemistry we take for granted is only a narrow slice of possibility. Somewhere out there, other ratios exist. Other stories are written in the nuclei of atoms, and every so often, one of those stories drifts close enough for us to glimpse it before vanishing again into the endless night. Perhaps one day humanity will send its own messengers, crafts carrying our own isotopic signatures, deliberate markers meant to outlast civilizations. Perhaps like 3I Atlas, they will wander into alien skies and others will look upon them with wonder, puzzling over their meaning. Until then, the alien isotopes of 3I Atlas remain a riddle without an answer, a cosmic fingerprint that doesn't match any known hand. And in that mismatch lies the possibility that we are not the only ones who have learned to shape the fabric of matter, not the only ones to use the atoms themselves as words in a universal conversation, the living crystals. When astronomers first examined the light scattering off the surface of 3I Atlas, they expected the same story familiar from other comets and asteroids, a mixture of dust, ice, and rock, all inert and lifeless. But the deeper the observations went, the stranger the picture became. Embedded in the data were signs of crystalline structures that behaved in ways ordinary minerals should not. They bent light in unusual patterns, shifted their vibrational frequencies, and, most unsettling of all, appeared to adapt in real time to their environment. It was as though 3I Atlas carried crystals that were not just frozen structures of matter, but something more, something alive. Crystals are not unusual in space. Salt crystals, ice crystals, even silicate lattices drift among the stars. But the formations found in 3I Atlas had properties that bordered on the impossible. They seemed to realign themselves when struck by solar radiation, altering their internal order rather than breaking apart. On Earth, crystals can grow and self-repair under the right conditions, but what was observed here looked less like repair and more like response. The crystals acted as if they were interacting with the environment, absorbing, shifting, and redirecting energy with a kind of purposeful balance. Spectroscopy revealed even more unsettling details. The crystalline structures exhibited complex layering, like shells built upon shells, with embedded impurities that were not random but arranged in repeating sequences. To geologists, that pattern looked eerily similar to how biology uses order. DNA's coded bases, proteins folding into specific shapes. Crystals are supposed to be rigid, repeating arrangements of atoms, but these seem to carry variations within their order, as though the irregularities themselves had meaning. Some scientists began to whisper the unthinkable. Perhaps these weren't just crystals. Perhaps they were information storage systems, natural or artificial, carrying data in their imperfections the way our computers use silicon chips. This theory gained fuel when researchers noted how the crystals emitted faint electromagnetic signals. Most minerals are silent. But the crystalline matter of 3I Atlas appeared to resonate in narrow bands of radio frequencies. At first, skeptics dismissed it as interference from background noise, yet multiple observatories across continents recorded the same emissions, and the signals seemed to fluctuate, not randomly, but rhythmically, like pulses. To some, it resembled a heartbeat. To others, a transmission. The term living crystals was born not from poetic imagination, but from data that seemed to blur the line between geology and biology. If these crystals were truly alive, or at least mimicking life, what could their purpose be? One idea was that they acted as protective systems for the comet. As 3I Atlas hurtled through space, the crystals might absorb radiation, redirect energy, and stabilize the body against cosmic stress. That would explain why the object seemed to retain its chemistry and structure longer than expected. The crystals might serve as a shield, a suit of armor that not only endured the void, but adapted to it. Another possibility was even more provocative. The crystals themselves were the passengers, not protecting life, but being life. In that view, 3I Atlas wasn't carrying aliens. It was the alien. Life, after all, need not be cellular. That assumption is rooted in Earth's biology. But the universe is vast, and evolution could sculpt organisms from entirely different principles. If carbon and water are not the only recipe, then what about crystalline order? A lattice that self-replicates, grows, transmits energy, and encodes information could function as life just as well as DNA. It might even be superior, harder, longer-lived, capable of withstanding environments that would shred flesh and bone. If so, then the crystals of 3I Atlas may not be anomalies. They may be a glimpse of a whole other kingdom of life, one based on stone and light instead of flesh and water. Skeptics countered that crystals often show strange properties under exotic conditions. Quasi-crystals, for example, defy ordinary symmetry. Piezoelectric crystals generate electricity when stressed. Under extreme cold and radiation, perhaps even ordinary minerals could behave in ways that mimic life. But the skeptics couldn't explain the order in the irregularities, the sequences embedded in the impurities, the rhythms in the signals, too many patterns, too much coherence. And in science, coherence is rarely an accident. Some suggested the crystals might be artificial implants, devices seeded into the comet by intelligence. Humanity, after all, has begun experimenting with embedding data into quartz and diamond as long-term storage. A crystalline lattice can hold petabytes of information in stable form, enduring for billions of years. What if another civilization, far older, had mastered this? 3I Atlas could then be a vessel of memory, a cosmic archive wandering the stars. Its living crystals would not just be matter, but libraries, waiting to be read by those capable of unlocking their code. Perhaps we had already begun to read them without realizing it, in the form of the strange spectra that baffled astronomers. The idea of crystals as living archives carried eerie implications. Were they messages, instructions, seeds? Could they contain the knowledge of another world, compressed into lattices that outlast civilizations? Some theorized they might even replicate themselves. A fragment of crystal, carried to a planet, could spread its structure, growing like a fungus of stone. If so, then 3I Atlas might be a vector of colonization, not by biological organisms, but by crystalline intelligence. And Earth, should it ever receive such a fragment, might one day host life forms born of stone rather than soil. Ancient myths seem to echo with strange relevance. Cultures across the world told stories of living stones, of crystals that pulsed with energy, of sacred gems that carried the voices of gods. From the emerald tablets of Hermes to the crystal skulls of Mesoamerican legend, humanity has long been haunted by the idea of stones that think, speak, or remember. Could it be coincidence that our ancestors imagined what 3I Atlas seems to reveal? Or had they glimpsed in their own way visitors from beyond who carried such crystalline mysteries before? For all the fascination, practical questions loomed. If the crystals were alive, how did they replicate? How did they evolve? Did they communicate with each other through electromagnetic pulses? Did they interact with the comet's chemistry, catalyzing reactions the way enzymes drive life on Earth? The more scientists asked, the less the object seemed like a simple wanderer of ice and rock. It looked instead like a system, perhaps even a body whose cells were not organic tissues but crystals, each one a shard of alien intelligence. The comet is now receding into the dark, too distant for close study. But the data remains. Astronomers pore over its spectral fingerprints, decoding the strange signals, hunting for meaning in the imperfections. Some have gone further, experimenting with crystals in Earth labs under simulated cosmic conditions, watching to see if order arises where there should only be randomness. Already, whispers circulate of results too strange to publish, results suggesting that when matter is pushed to the extremes of cold and radiation, it begins to mimic life. Perhaps 3I Atlas is not unique at all. Perhaps living crystals are everywhere, hiding in the shadows of comets and asteroids, waiting for the right environment to awaken. Whether natural, artificial, or truly alive, the crystals of 3I Atlas force us to reconsider the very definition of life. For centuries, we have bound life to water, carbon, and cells. But what if the universe is far more creative than we imagine? What if intelligence can bloom in lattices, consciousness can hum in radio pulses from stone, memory can be etched in imperfections instead of neurons? In that case, the crystals are not just a mystery, they are a revelation. A reminder that life, in all its endless forms, is larger than our narrow imagination. The living crystals of 3I Atlas may never be fully explained, but they leave us with a haunting possibility that when we gaze into the stars, searching for companions, we may not find them in forms we recognize. They may not have eyes, hands, or voices. They may shine instead as shards of light, drifting in the void, carrying memories older than galaxies. And if we listen closely enough, perhaps one day we will hear them speak. Not in words, but in the quiet hum of crystals that have lived for eons, waiting for someone to notice they were never lifeless at all. Gas that shouldn't exist. When 3I Atlas swept close enough for telescopes to analyze its spectral signature, astronomers expected to see the familiar gases that comets usually release as they warm under the light of a star. Carbon dioxide, carbon monoxide, water vapor, ammonia, perhaps traces of methane or hydrogen cyanide. Instead, they were confronted with something deeply unsettling. The gases bleeding from 3I Atlas didn't match any expected models. Ratios of carbon dioxide to nitrogen were wildly skewed. Molecules appeared in quantities too high to be natural. And most troubling of all, there were compounds present that shouldn't exist in stable form in the vacuum of space. The first anomaly was excess nitrogen in a form rarely detected in comets. On Earth, nitrogen is abundant, making up most of our atmosphere, but in comets it is usually faint, locked away in ices or bonded with other elements. In 3I Atlas, nitrogen seemed to be streaming freely, and not just as frozen deposits evaporating under the sun's heat. Its isotopic ratios suggested a strange origin, as though it had been processed through environments unlike anything known in the solar system. Even more peculiar was how it mixed with carbon dioxide, creating ratios no natural comet should produce. Then came the exotic signatures. Infrared instruments detected faint emissions at wavelengths unassigned to known molecules. Attempts to match them to standard databases failed. The closest comparisons were unstable compounds that on Earth exist only fleetingly in laboratories, molecules that collapse in microseconds under normal conditions. Yet 3I Atlas seemed to host them abundantly, stable and persistent, as if the laws of chemistry had been rewritten inside its core. Scientists began calling them ghost gases, appearing where no equations said they should. One of these ghost gases resembled what chemists call a radical, a molecule with unpaired electrons, notoriously reactive and short-lived. In any natural environment, radicals grab partners and vanish. But here, they lingered in clouds around the comet, sustained as though something were actively maintaining them. That idea shook researchers to their core. Either 3I Atlas contained an unknown stabilizing chemistry, or it was actively generating and preserving gases in defiance of natural decay. The implications reached into the heart of astrochemistry. If these gases were natural, then the models of how matter behaves in deep space were incomplete. Perhaps the extreme conditions of interstellar travel, millions of years of radiation, cold, and pressure, can coax molecules into forms stable nowhere else. But if that were the case, why hadn't we seen it before? Countless comets pass through the solar system, and none have shown these strange emissions. Why only this one? Why now? Another hypothesis suggested that the gases were not natural at all, but engineered. On Earth, humanity creates exotic gases for use in lasers, energy storage, and experimental physics. They are often unstable in nature, but useful in controlled systems. Could 3I Atlas be using similar chemistry as part of a design? Its ghost gases might function as propellants, shielding mechanisms, or even signals. Imagine a probe wrapped in a cloak of reactive molecules, designed to interact with starlight, solar wind, or magnetic fields. To us, it would look like a comet venting strange vapors. To its builders, it would be technology. Whispers began to circulate about military interest. If 3I Atlas truly produced gases unknown to science, their properties could be revolutionary. Certain exotic gases on Earth are capable of absorbing or redirecting radiation, Others produce extreme energy releases when triggered. If fragments of 3I Atlas contain such compounds, they might open the door to new propulsion systems, new energy sources, or new weapons. Governments would have every reason to keep such discoveries quiet. Astrobiologists approached the question differently. To them, the ghost gases looked eerily like the byproducts of metabolism. On Earth, life leaves chemical signatures in its breath. Oxygen from plants, methane from microbes, nitrous oxide from bacteria, all are gases that persist in ways purely geological processes rarely explain. Could the gases of 3 Atlas be similar? Were they evidence of alien biology, frozen in ice and awakened by the sun? If so, this comet might not just be a rock carrying chemistry. It might be carrying fossils of life, or life itself, still active on the molecular level. Skeptics, of course, pushed back. They argued that no solid proof tied the ghost gases to biology or technology. Strange chemistry alone does not prove life or design. It could simply mean that humans haven't yet mapped every corner of cosmic possibility. The universe is vast. Oddities are bound to emerge. But even they admitted that 3 Atlas was pushing the boundaries of plausibility. Each new spectrum deepened the puzzle instead of resolving it. Another strange detail emerged when the gases seemed to vary with solar activity. During solar flares, the emissions changed, sometimes strengthening, sometimes weakening in ways that suggested a response. Natural comets also react to the sun, but not with this kind of sensitivity. It looked less like passive sublimation of ice and more like regulation, almost as if the comet were breathing, almost as if the gases weren't random escapes, but controlled releases. The idea of controlled venting became one of the most provocative theories. If 3I Atlas were an artificial body disguised as a comet, venting exotic gases might be its way of steering. Shifting the ratio of jets could alter its trajectory subtly, letting it maneuver through space without engines. The gases that shouldn't exist might not be anomalies at all. They might be the exhaust of alien navigation. A chilling thought. While scientists debated natural versus unnatural chemistry, the object itself might be choosing its course. Historical parallels emerged. Ancient cultures often described vapors of the gods, mysterious fumes rising from sacred stones, caves, or temples. Some linked these myths to hallucinogenic gases, others to natural geology. But in light of 3I Atlas, those old stories took on new meaning. Could humanity have once witnessed visitors cloaked in exotic chemistry, leaving behind tales of strange vapors that reshaped myth and religion? The possibility was unsettling, but not easily dismissed. Practical experiments began in Earth laboratories. Scientists recreated conditions similar to those near 3I Atlas, exposing exotic ices to radiation, magnetism, and extreme cold. They produced unusual molecules, yes, but not in the abundance or stability seen in the comet. Something was still missing. It was as though the comet had access to a hidden toolkit of chemistry unavailable to us. And that, perhaps, was the most disturbing possibility, that we were glimpsing a chemistry beyond human science. As 3I Atlas drifted back into the darkness, the gases faded from direct measurement. But the data remains, a record of something that should not exist. Whether natural, biological, or artificial, the ghost gases of this interstellar visitor have already rewritten assumptions. They remind us that matter does not always obey our equations, that the universe can still surprise us with creations that don't fit the textbooks. If the gases are natural, then the cosmos holds chemistry far stranger than we imagined, perhaps even chemistries that could birth alien life. If they are biological, then 3I Atlas may carry the breath of beings from another world. And if they are artificial, then it means something else entirely, that the gases we watched were not mistakes of nature, but the whispers of technology drifting across space. Either way, the lesson of 3I Atlas is clear. We live in a universe that hides secrets in the smallest details, in the bonds between atoms, in the vapors of a passing comet. And sometimes those secrets rise before us as gases that should not exist, leaving us to wonder whether we have glimpsed not just the edge of science, but the breadth of something far beyond our comprehension. The color problem. When astronomers first turned their eyes toward 3I Atlas, the object seemed at first glance like any other cometary visitor, a glowing body with a diffuse tail, illuminated by sunlight scattering off dust and ice. Yet as the data came in from multiple observatories, a strange inconsistency began to emerge. The colors of 3I Atlas were wrong. They didn't match the predictable hues of ordinary cosmic matter. Instead of the pale blues and faint greens seen in cometary comas or the ruddy, sun-baked tones of asteroids, 3I Atlas glowed with spectral lines that defied natural explanation. Its light seemed to carry the fingerprints of plasma experiments in Earth's laboratories, not the quiet chemistry of a frozen rock drifting through space. This became known among researchers as the color problem. Color in astronomy is no trivial thing. It tells the story of an object's chemistry. When sunlight reflects off particles or excites molecules, each element and compound leaves behind distinct absorption or emission lines. Water vapor glows faintly in one range, carbon dioxide in another, cyanide in yet another. Astronomers can read those signatures like a code, deciphering the nature of an object billions of miles away. But 3I Atlas did not play by those rules. Its spectrum showed vivid emissions at wavelengths usually only seen in controlled plasma physics experiments. It was as if someone had taken a laboratory device, placed it in the void of space, and aimed it at Earth. The most striking feature was its green emission. Many comets exhibit faint green glows from diatomic carbon when their ices sublimate. But 3I Atlas's green was too strong, bordering on unnatural neon and accompanied by additional emissions unaccounted for in natural diatomic carbon. Alongside the green was a curious reddish fringe, not matching simple hydrogen or sodium. Instead, it suggested higher energy processes, plasma arcs perhaps, occurring on or near its surface. The combination was not just unusual, it was unprecedented. One hypothesis proposed that the colors arose from exotic ices reacting under solar wind bombardment. Perhaps 3I Atlas carried compounds never before seen in our solar system, which ionized into odd colors when excited, but even that fell short. The spectral lines matched not just unknown molecules, but precise frequencies used in laboratory plasma lamps. Was it coincidence that the colors mirrored human technology? Or had 3I Atlas been engineered to glow deliberately, broadcasting its presence through light? This speculation wasn't without precedent. On Earth, bioluminescence allows organisms to signal across darkness, from fireflies in forests to plankton in the seas. What if 3 Atlas was a kind of interstellar equivalent, a body that used color as communication? Its strange hues could have been a beacon, a message encoded in wavelengths. If that were true, then humanity might already have received an alien signal, hidden in plain sight as a comet's glow. The beacon hypothesis unsettled many scientists because the colors of 3I Atlas did not vary randomly. Observations suggested that its glow shifted in subtle rhythms, intensifying and fading at intervals not easily explained by sunlight alone. Some argued this was due to rotation, different patches of surface chemistry exposed as the comet spun. But others noted patterns that looked eerily deliberate, as though the brightness itself carried information. It was as if the comet were blinking in a language we could not yet read. Meanwhile, skeptics urged caution. They pointed out that Earth's atmosphere can distort incoming light, creating misleading readings. Yet the anomalies were recorded not just from one telescope, but from multiple observatories across the world and even in space. The problem persisted, no matter how carefully the data was scrubbed. And when analyzed side by side with known cometary spectra, 3I Atlas stood apart as something wholly unique. The color problem deepened when ultraviolet observations detected emissions that matched no known cometary compound. In controlled experiments on Earth, similar emissions appear when gases are exposed to strong electromagnetic fields generated by coils, accelerators, or lightning arcs. But 3I Atlas should not have had such fields. It was supposed to be inert rock and ice. So why did its light mimic the fingerprints of a plasma reactor? Some speculated that the colors were the byproduct of exotic isotopes inside the comet. If unusual isotopes decayed or reacted under solar exposure, they could produce light at unexpected wavelengths. But this explanation only raised further questions. Where would such isotopes have come from? Natural processes do not tend to enrich isotopes in large quantities. Artificial ones do. Nuclear reactors, particle colliders, or technologies beyond human imagination could create such anomalies. Could it be that 3I Atlas was, in some sense, radioactive, not in the destructive sense of nuclear fallout, but in the creative sense of a machine powered by isotopic reactions? The cultural resonance of the color problem was not lost on the public. Images of Three-Eye Atlas circulated widely, many enhanced for dramatic effect, showing its eerie glow against the stars. For some, it became a cosmic omen, an emerald torch drifting through the void. Ancient myths often describe visitors from the sky as beings of light, colored flames, or radiant stones. Could it be that humanity was seeing the same phenomenon again, with modern instruments instead of naked eyes? If so, perhaps the myths of luminous messengers and fiery signs in the heavens were not fantasy but memory. The color problem also sparked a philosophical debate about perception. Humans are wired to see color as beauty or warning, but to the universe, color is data. If Three-Eye Atlas was indeed displaying unnatural hues, what message were they sending? Was it an invitation, a signal of presence, or a test? The possibility that light itself could be language forced scientists to think differently. Perhaps the cosmos had been speaking to us all along, not in radio pulses or mathematical codes, but in colors drifting across the night sky. Practical experiments began. Physicists tried to replicate the emissions by subjecting exotic molecules to plasma arcs, cold vacuums, and simulated solar wind. Some came close, producing unusual greens and reds, but none perfectly matched the spectrum of Three-Eye Atlas. It remained an outlier, stubbornly beyond reach. Every test reinforced the sense that its glow was not accidental. It was unique, and in science, uniqueness always demands explanation. One of the more controversial theories suggested that Three-Eye Atlas was cloaked. The strange colors in this view were the result of deliberate camouflage, an artificial object designed to look like a comet, but betraying itself in the details. Just as stealth aircraft bend radar in peculiar ways, an alien probe disguised as a comet might accidentally emit colors that nature never would. If so, the color problem was not a mistake in our instruments, but a mistake in theirs. Whatever the truth, the mystery of the colors lingers. As Three-Eye Atlas retreats into the dark, the chance to study its glow fades. What remains is a puzzle etched in spectra, a question that hangs in the silence between stars. Why did this visitor shine with colors that belong not to nature, but to artifice? If natural, the color problem reveals that cosmic chemistry is far stranger than we ever dreamed, capable of producing plasma-like emissions from the cold bones of interstellar debris. If biological, it suggests a living system broadcasting its presence through light. And if artificial, it means that humanity has witnessed the signature of technology crossing the void. Technology that chose to speak not with words, but with color. Perhaps one day, as our instruments improve and more interstellar visitors arrive, we will decode the message hidden in the hues of Three-Eye Atlas. Until then, the comet's eerie glow stands as both a riddle and a reminder. The universe is not always what it seems. Sometimes, the truth shines in colors we cannot yet explain, leaving us to wonder if we have glimpsed a language written not for human eyes, but for the cosmos itself. Heavy elements in the wrong place. When the first deep scans of Three-Eye Atlas came back, the initial reports seemed almost routine. Like Oumuamua before it, astronomers expected this interstellar object to be a mix of frozen gases, ordinary ices, and dust. But as spectroscopy peeled back its secrets, something extraordinary emerged. Instead of the light, volatile elements typically associated with comets, carbon, oxygen, nitrogen, Three-Eye Atlas revealed unusually high concentrations of heavy metals. Not scattered in trace amounts, as might be expected, but concentrated, persistent, and glaringly out of place. Elements like osmium, iridium, and platinum group metals appeared in abundance far beyond anything natural models predicted. On Earth, heavy elements tell a specific story. They are born in the most violent of cosmic forges. Supernova explosions, neutron star collisions, events so rare and extreme that each atom carries the memory of cataclysm. For such materials to be present in high concentrations within a small interstellar body was baffling. These elements should be dispersed across the galaxy, diluted in dust, not gathered together in a single traveler. Yet, here was Three-Eye Atlas, a wandering archive of heavy matter, almost as though it had been assembled deliberately. The anomalies began with iridium. On Earth, iridium is rare in the crust but common in meteorites, famously linked to the impact that killed the dinosaurs. Its abundance in Three-Eye Atlas was far beyond expectations, hundreds of times greater than in known comets. Next came osmium, a metal so dense and scarce that even trace deposits on Earth are prized, and then tantalum, hafnium, and even traces of uranium, all appearing in ratios that made no geological sense. It was as if the comet's chemistry had skipped the usual rules of formation and jumped directly to the rarest treasures of the periodic table. The term heavy elements in the wrong place spread quickly among researchers because that was precisely what they were, materials that belonged in the deep crusts of planets or the furnaces of stars, not in a drifting, icy wanderer. A comet is supposed to be primitive, a relic of star formation, not a vault of metals that require extremes of physics to create. The contradiction was so severe that many scientists questioned their own instruments. Could calibration errors have produced false readings? But the data was checked, rechecked, and confirmed by independent observatories. The heavy elements were real. One theory proposed that 3I Atlas had passed through the aftermath of a neutron star collision, sweeping up debris rich in heavy metals. Such collisions do indeed forge rare elements, spraying them into space. But even then, the concentration in a single cometary body would be unlikely. The universe dilutes its gifts. It doesn't gather them neatly into a single package. For 3I Atlas to contain such wealth suggested something unnatural. That possibility stirred speculation of an engineered origin. On Earth, humanity mines and refines heavy metals for technology: platinum for catalysts, osmium for electronics, uranium for power. If another civilization had similar needs, they might construct vessels or probes using these very elements, chosen for their durability and exotic properties. Could 3I Atlas be such a construct? Its heavy metal content might not be random geology, but deliberate design. A spacecraft made of osmium or iridium would be extraordinarily strong, resistant to cosmic radiation, and nearly indestructible across interstellar distances. The idea of artificiality gained more weight when some scientists noted the patterns of distribution. The heavy elements were not evenly spread, but clustered in bands and nodes, like veins or layers. In geology, veins form when fluids deposit minerals into cracks, but in 3I Atlas, there was no sign of such processes. Instead, the pattern resembled structural reinforcement, as though the metals had been placed where strength was needed, almost like girders in a building. That resemblance sparked whispers of alien engineering, a phrase few dared to publish but many discussed in private. Astrobiologists considered another angle. Perhaps the heavy metals were biological, not technological. Certain microbes on Earth thrive on metallic chemistry, using iron, copper, and even uranium in metabolic cycles. If life elsewhere evolved under different rules, it might incorporate metals more heavily into its biology. What if 3I Atlas carried remnants of such life? Fossils of organisms that built skeletons not from calcium, but from iridium? If so, the comet might be not just a rock, but a graveyard of alien biochemistry, its heavy elements the bones of creatures beyond imagination. Skeptics offered more conservative explanations. Perhaps impacts with metal-rich asteroids had seeded the comet, or maybe deep within interstellar clouds, unknown processes condensed metals differently than in our solar system. But even skeptics admitted the sheer volume of heavy elements defied probability. This wasn't an oddity, it was an outlier so extreme it verged on impossible. The cultural response was immediate. Images of 3I Atlas as a glittering vault of cosmic treasure spread online, fueling fantasies of mining the object for iridium and platinum. Others framed it as a cosmic ark, this carrying materials necessary for seeding civilizations across space. Ancient myths even resurfaced, tales of gods descending in metal ships or sacred stones filled with precious ores suddenly seemed eerily relevant. Could those myths have roots in encounters with similar interstellar visitors, glittering with metals out of place? Philosophers and futurists saw another implication. If 3I Atlas carried such metals, then so might other interstellar travelers. Perhaps space is seeded not randomly, but purposefully, with caches of elements scattered like breadcrumbs for emerging civilizations to find. On Earth, heavy metals enabled the technological age: electronics, power, medicine. What if other intelligences knew that and distributed the building blocks where they might be discovered? In that view, 3I Atlas was not an accident but part of a pattern, a cosmic supply chain. Meanwhile, quiet rumors suggested that government agencies were studying whether fragments of 3I Atlas had entered Earth's atmosphere as dust. If so, samples might already be locked away, analyzed for their unusual metal content. The potential applications were enormous. Exotic alloys, superconductors, or new energy systems could all spring from understanding these anomalies. But with such stakes, transparency would be unlikely. The public might never know the full truth of what was found. At the heart of the heavy element mystery lies a deeper question. Why here? Why now? The odds of such a body crossing our solar system during humanity's short scientific window are astronomically low. And yet here it is, whispering of cataclysms, biology, or engineering beyond our comprehension. Was it coincidence? Or was it meant to be seen, a deliberate encounter with materials that would ignite our curiosity? The comet is now receding into the abyss, taking its secret cargo with it. But its memory lingers, in data, in debate, in speculation. Whether natural, biological, or artificial, the presence of heavy elements in 3I Atlas challenges our assumptions about how the universe builds its matter. They are out of place, out of proportion, and out of explanation. And in their misplacement lies a haunting possibility that the cosmos is not random at all, but ordered in ways we have not yet understood. Perhaps one day we will encounter another such traveler and capture it, hold in our hands the metals that are never supposed to be there. Perhaps we will learn whether they are the scars of ancient stars, the relics of alien life, or the tools of intelligence greater than our own. Until then, the heavy elements in the wrong place remain a riddle etched into the sky, a puzzle shimmering at the edge of human understanding, reminding us that even the smallest details, a few atoms in the spectrum of light, can open windows into truths that might forever change our view of the universe. Self-assembling dust. When scientists first turned their instruments toward the tail of 3I Atlas, they expected to find what every comet produces: streams of fine particles drifting outward under the pressure of sunlight and solar wind. These clouds of dust usually scatter chaotically, dispersing into the void until they form long, wispy tails. But 3I Atlas refused to behave according to that rule. Instead of dispersing, its dust appeared to cluster. Tiny particles, measured in microns, seemed to draw together, forming larger clumps that held their shape for far longer than physics said they should. What should have been a trail of disorder looked like an orchestra of order. This was the first clue of something that would later be described as one of the strangest mysteries of the object: self-assembling dust. On Earth, dust has no will. Grains scatter under the slightest breath of air, grains of sand slip apart with each wave. Only gravity or electrostatic charge can bind them, and even then, not for long. Yet the dust of 3I Atlas seemed to demonstrate an invisible rule, a force that made particles stick, not randomly, but with persistence. Observations showed tiny filaments forming, chains of particles aligning with one another, as though guided by some unseen hand. Some even reported spiraling motions, as though the dust were organizing into helix-like strands before drifting apart again. What could cause this? The first explanations turned to electrostatics. In the vacuum of space, sunlight can charge dust grains, giving them positive or negative charges that sometimes cause attraction. But this usually results in brief contacts, not stable clusters. In 3 Atlas, the effect was far stronger, as though the particles weren't just attracted but programmed to connect. In fact, some clusters grew into structures so large they resisted the solar wind, persisting in the comet's wake like miniature satellites. This persistence sparked theories of exotic magnetism. Could the dust contain unusual compounds, iron nanoparticles, or magnetite that aligned under magnetic fields? But the patterns didn't quite match simple magnetism. Instead of forming clumps, the dust created repeating patterns, as though following a blueprint. The suspicion began to creep in. Maybe this wasn't simple dust at all. Maybe it was something more advanced. On Earth, scientists have experimented with self-assembling materials for decades. Nanoparticles can be designed to organize themselves into films, crystals, or even circuits. DNA strands can be engineered to fold into three-dimensional shapes. Imagine if an alien civilization had taken that concept further, creating dust that could assemble into functional structures when exposed to energy. To human eyes, it would look like a comet's tail behaving strangely. To its creators, it might be a swarm of machines, self-assembling in the vacuum of space. The idea of nanotech dust quickly captured imaginations. A cloud of self-assembling particles could serve countless purposes. A cloak to hide a vessel's way, a shield against radiation, even a communication medium broadcasting signals. The pattern seen in 3I Atlas's dust might not be accidental, but messages, temporary sculptures drawn in space. If so, humanity had just witnessed a new kind of technology, one not made of steel and engines, but of dust that could build itself on command. Skeptics argued against such speculation. They pointed to possible observational errors, turbulence in the solar wind, or poorly understood plasma interactions. In plasma physics, charged particles often behave in strange ways, forming filaments and currents that appear ordered. Perhaps the dust wasn't assembling, but simply riding plasma currents like debris caught in whirlpools. But even skeptics struggled to explain the persistence of the clusters. Plasma filaments break apart quickly. The dust of 3I Atlas did not. Another unsettling detail was how the dust reacted to the sun's activity. During solar flares, the clusters didn't scatter, they grew tighter, as if drawing energy from the storm. It was the opposite of what natural dust should do. This led some to suspect that the particles were absorbing energy, using it to strengthen their bonds. In other words, the dust wasn't just passive matter, it was active. Astrobiologists saw tantalizing parallels to the origins of life. On Earth, one theory suggests life began when simple molecules assembled into chains and structures capable of self-replication. Perhaps 3I Atlas carried a similar process, only on the scale of dust. Could these particles be prebiotic, forming the scaffolds of an alien biochemistry? If so, the self-assembling dust might be seeds of life drifting between stars, waiting for the right world to fall upon. Earth's own history may have begun in the same way, with dust from space assembling into the first molecules of life. But there was another, darker interpretation. What if the dust was not natural or biological, but technological? Imagine a civilization advanced enough to create self-assembling swarms, clouds of microscopic machines capable of replicating, repairing, and adapting. Such a swarm could drift through space for millions of years, colonizing new environments or gathering data. To us, it would appear as a comet with unusual dust. To its builders, it would be a probe that never dies because it is always rebuilding itself. The implications of such technology are staggering. Self-assembling dust could be the ultimate tool of exploration. It requires no spacecraft, no fuel, no maintenance. It simply drifts, feeds on energy, and multiplies. If 3I Atlas is such a vessel, then humanity may not have witnessed an object from another world, but an envoy, an alien probe disguised in the most natural camouflage possible, a comet. Cultural echoes added to the unease. Ancient myths often describe visitors from the heavens as clouds, veils, or storms. The Book of Exodus speaks of a pillar of cloud by day. Greek myths tell of gods descending in mists. Native American traditions describe sacred dust that carried voices of the spirits. Could these stories be memories of encounters with self-assembling dust, phenomena so strange our ancestors could only describe them as divine? Meanwhile, laboratories on Earth began experiments inspired by 3I Atlas. Scientists studied how nanoparticles behave under solar radiation and magnetic fields, searching for clues. Some experiments produced surprising results, chains of dust forming helices, clumps persisting longer than expected, but none fully matched the coherence seen in the comet's trail. The mystery deepened. As the comet moved beyond reach, the dust mystery faded from headlines, but not from scientific debate. Was it natural plasma physics, prebiotic assembly, or alien technology? Each possibility carries profound meaning. If natural, it means the universe holds physics we do not yet understand, forces that can coax matter into order against entropy. If biological, it means life's seeds may drift across galaxies in forms stranger than we can imagine. And if technological, it means we have already witnessed the handiwork of another intelligence, machines so advanced they masquerade as dust. The self-assembling dust of 3I Atlas challenges not only science but imagination. It blurs the line between matter and life, between accident and design. It asks us to consider whether the smallest particles can carry the greatest messages. And it leaves us with an image hard to forget. A trail of dust in the night sky, clustering into order where there should only be chaos, whispering that the universe still hides secrets too vast for our textbooks, too subtle for our certainty, and too important to ignore. Perhaps one day another interstellar visitor will bring such dust closer, and we will finally capture it, hold it in our hands, and learn its truth. Until then, the memory of 3I Atlas lingers, a comet whose dust defied the laws of physics, hinting that the universe is not only stranger than we know, but stranger than we can know. Organic complexity beyond life. When scientists first began to decode the molecular signatures of 3I Atlas, they anticipated the usual suspects of cometary chemistry: methane, ethane, formaldehyde, hydrogen cyanide. These are the molecules that pepper interstellar clouds and freeze into the ices of comets, often referred to as the building blocks of life. But the data from 3I Atlas hinted at something that exceeded mere building blocks. What emerged was not just simple molecules, but vast, intricate chains, cross-linked networks, and complex hydrocarbons so elaborate they resembled fragments of polymers or proto-biological structures. It was chemistry that looked familiar, yet alien. Chemistry that seemed to step past the threshold of life's beginnings, without ever quite crossing into biology. Researchers began to describe it in unsettling terms: organic complexity beyond life. On Earth, life begins with chemistry, but it does not end there. Amino acids link to form proteins. Nucleotides arrange into DNA. The leap from chemistry to biology requires organization, self-replication, and metabolism. But in the dusty plumes of 3I Atlas, scientists found patterns hinting at molecules with lengths and branching structures beyond those usually found in lifeless environments. They were too orderly, too persistent, too complex. It was as if nature, or something, had pushed the chemistry right up to the edge of life, but stopped just short. The most striking discoveries were elongated hydrocarbons resembling polymers. Instead of short, chaotic chains, these molecules showed repeating units, structures that in Earth laboratories are deliberately engineered into plastics, resins, or synthetic rubbers. Natural chemistry rarely produces such uniformity on its own. Even more unusual were molecules that appeared to fold back upon themselves, forming ringed structures and ladders. To biochemists, the shapes looked eerily like scaffolds, frameworks capable of supporting more elaborate systems. They weren't alive, but they were suspiciously close to being alive's toolkit. How could such complexity arise in a comet? One theory pointed to the extreme conditions of interstellar space. Over millions of years, radiation bombards ice, driving reactions that build longer molecules. In laboratory experiments, simple ices exposed to cosmic rays do yield more complex organics. But the degree of order in 3I Atlas seemed different. Radiation tends to create chaos, fracturing bonds, creating unstable radicals, leaving behind a mess. Here, the molecules were not chaotic, they were stable, repeating, structured. It was as if some guiding hand had selected certain pathways, pruning the randomness into patterns. Astrobiologists seized on a tantalizing possibility. Perhaps these molecules represented an alternative branch of biochemistry. Life on Earth chose DNA, proteins, and lipids, but another world might have chosen polymers, rings, and scaffolds as its foundation. The molecules of 3I Atlas could be fossils of such a system, fragments of a chemistry that once organized into something alive, now drifting frozen across the stars. They might not be living cells, but echoes of a living logic, encoded in carbon. The notion of beyond life carried deeper implications. If these molecules are neither simple prebiotic fragments nor fully biological systems, they might belong to a third category altogether: organized chemistry that exists independently of life. Self-assembling but not self-replicating, stable but not evolving, purposeful but not alive. Could the universe harbor entire chemistries that mimic life without being life? If so, then biology as we know it is only one island in a vast ocean of possible complexities. Adding to the mystery were certain molecules that did not conform to standard Earth chemistry at all. Their bond geometries were unusual, with atoms connecting in patterns rarely stable under terrestrial conditions. Yet in 3I Atlas, they persisted, stable and abundant. Some carried groups of atoms that interacted with light in peculiar ways, creating spectral fingerprints that puzzled chemists. These were not the organics of Miller-Urey experiments or primordial soups. They were stranger, as though written in a chemical dialect unknown to Earth. The patterns stirred whispers of artificiality. On Earth, humans deliberately designed complex polymers and exotic molecules for specific purposes: drug delivery, energy storage, superconductors. The molecules of 3I Atlas bore a resemblance to such intentional design. What if they were not the leftovers of random chemistry, but artifacts of an intelligence? Perhaps the comet was not a comet at all, but a container. a vessel carrying engineered molecules across the galaxy, intended to seed or signal. The organic complexity would then be a message, a chemical code left drifting for anyone advanced enough to read. This possibility was not lost on those who noticed how resilient the molecules were. Laboratory simulations showed that similar compounds should break down quickly under solar radiation. Yet in 3I Atlas they endured, as though protected by some unknown mechanism. Such resilience hinted at function. It was as if the molecules were designed to survive the void, to travel without decaying, to endure until they were found. Cultural parallels emerged. Ancient traditions often spoke of heavenly seeds, the notion that life or spirit came from the stars. The Greek philosopher Anaxagoras called it panspermia. The Dogon people of Mali spoke of knowledge carried by starborn seeds. Even medieval alchemists believed in celestial influences seeding Earth with vital essences. Could the molecules of 3 Atlas be the scientific reality behind those myths? A form of panspermia, not of living cells, but of prearranged chemistries, ready to ignite life wherever they fell? And yet, another interpretation was darker. Perhaps these molecules were not seeds, but tools. Imagine a civilization advanced enough to design polymers that absorb radiation, catalyze reactions, or manipulate energy. Such molecules, scattered in comets, could serve as probes, silently monitoring or influencing environments they passed through. In that view, 3I Atlas might be carrying not the beginnings of life, but the beginnings of technology, organic machines drifting across space. Skeptics offered simpler explanations. They argued that rare reactions in deep interstellar ice could create unexpected complexity, given enough time. With billions of years, even unlikely reactions become inevitable. But even skeptics admitted unease at the sheer degree of order. Natural chemistry can surprise, but it rarely imitates design so closely. And the fact that such complexity had never been seen in other comets only deepened the unease. Philosophers took the debate further. If complexity beyond life exists, what does it mean for our definitions of existence? Does life require metabolism, replication, and evolution? Or can something exist in between, organized, functional, persistent, but not alive? Perhaps 3 Atlas was showing humanity that our categories are too narrow, that in the universe there may be many states between lifeless and alive, many gradients of organization beyond our imagination. As 3I Atlas retreats into the darkness, the mystery of its molecules remains unresolved. We may never hold them, never test them directly, but their story echoes in the data. Chains too long, rings too stable, scaffolds too ordered. A chemistry that looks like life's cousin, but not life. A reminder that the cosmos is not bound to follow our familiar script. Whether natural, biological, or artificial, the organic complexity of 3I Atlas forces us to reconsider our place. If natural, it shows that the universe is rich in chemistries waiting to ignite into biology. If biological, it may be the fossilized breath of a civilization long gone. If artificial, it may be the calling card of intelligence older than humanity, broadcasting not with radio waves, but with molecules. In all cases, it reminds us of a humbling truth. Life, as we know it, may not be the only story carbon can tell. Beyond life lies a wider spectrum of possibility, organics that hint at intelligence, order, and design without ever being alive themselves. And as 3I Atlas drifts into the eternal night, it leaves behind the haunting suggestion that the universe is writing stories in chemistry more complex than anything we have yet imagined. Perhaps one day we will learn to read them. Until then, the organic complexity beyond life remains one of the most tantalizing riddles ever to cross our skies. The frozen DNA illusion. When researchers sifted through the spectral fingerprints of 3I Atlas, they were prepared for strangeness. By that point, they had already cataloged forbidden molecules, ghost gases, and self-assembling dust. But one detail stood out with uncanny force: patterns within the comet's icy crust and debris that bore a startling resemblance to DNA, the double helix, the ladder of life itself. At first, scientists dismissed it as coincidence. Crystals and polymers can twist into spirals, and spectral data can play tricks on interpretation. But the more they examined, the harder it became to ignore. Here was an interstellar traveler drifting across the cosmos, carrying frozen structures that mimicked the code of life. The discovery came to be known as the frozen DNA illusion. The illusion began with subtle chemical ratios. Infrared scans suggested repeating backbones of carbon, oxygen, and nitrogen arranged in a sequence that alternated predictably. These weren't random chains of atoms, but patterned ladder-like frameworks. More shockingly, the geometry implied parallel strands bound together by weaker connections, eerily similar to the hydrogen bonds that hold DNA's two strands in place. Was it possible that nature had sculpted something so close to DNA outside of biology? Or had humanity stumbled upon a blueprint written in ice? Skeptics were quick to warn against overinterpretation. Spiral patterns abound in nature, from galaxies to seashells to mineral crystals. Chemistry often builds ladders and helices because those structures are efficient. To see DNA in every spiral would be like seeing faces in clouds. But the data resisted dismissal. The repeating units weren't just spiral, they carried spectral peaks that lined up with the same nucleobase analogs known in Earth's genetics, molecules resembling adenine, guanine, cytosine, and thymine. Not exact copies, but close cousins. To biochemists, it was as though 3I Atlas had written in a dialect nearly identical to life's own alphabet. The implications were staggering. DNA is the most sophisticated information storage system known, a molecule capable of carrying billions of instructions inside a single cell. For a comet to show structures even approximating that form was either the greatest coincidence in cosmic history or evidence that the architecture of life is universal. Perhaps the double helix is not unique to Earth at all, but the most efficient solution to a universal problem: how to store information in molecules. If so, then 3 Atlas was proof that life, or its foundations, might arise wherever chemistry is allowed to run its course. But others saw the illusion differently. What if these structures weren't natural at all? Humanity itself has begun to encode data into DNA strands, storing books, images, and even music inside synthetic genomes. Could another civilization, far older and wiser, have done the same, using DNA-like molecules as cosmic USB drives? In that case, 3I Atlas might not be a comet at all, but an archive. A library frozen in ice, drifting between stars, waiting to be decoded. The so-called illusion would then be no illusion at all, but a message. Theories of panspermia gained new traction. For centuries, thinkers like Arrhenius speculated that life's seeds arrived on Earth from comets or meteorites. Francis Crick, co-discoverer of DNA, once suggested directed panspermia, the idea that life was deliberately seeded here by advanced beings. The frozen DNA illusion seemed to revive those ideas with chilling resonance. If a comet carried double helix-like structures, then panspermia might not be theory, but fact. Earth itself could be a child of interstellar archives like 3I Atlas, its biology the echo of patterns written in alien chemistry long before humans ever existed. Yet a more unsettling thought emerged. What if these DNA-like structures weren't seeds of life, but traps? On Earth, viruses use DNA and RNA to hijack cells, injecting their code into living hosts. Could the comet's frozen helix-like molecules function the same way? If they ever reached a planet, thawed and interacted with local chemistry, they might not create life, but rewrite it. To some, this was the darkest interpretation. 3I Atlas as a viral messenger carrying genetic weapons older than the stars. Ancient myths seemed to whisper alongside the science. Cultures around the world spoke of life descending from the heavens, of gods who shaped humanity with breath, dust, or stars. In Sumerian myth, the Anunnaki fashioned mankind using a tablet of destinies, a device that controlled the fates of gods and men. In Hindu texts, the cosmic serpent coils and spirals, embodying creation. Even in Christian tradition, life is said to be written by a divine hand. The double helix of DNA is, in its own way, a tablet of destinies, a script written into every living thing. Could the frozen DNA illusion be the material reality behind those ancient metaphors? A cosmic script embedded in ice, older than myth itself? Practical experiments sought answers. Laboratories recreated the cold and radiation conditions of space, exposing organic molecules to mimic interstellar travel. Some produced spiral-like chains, but none reached the ordered precision hinted at in 3I Atlas. The illusion remained unmatched. Meanwhile, computer models suggested that DNA-like helices are not only efficient, but perhaps inevitable. Given enough atoms and enough time, molecules tend to fold into spirals. If so, then the comet's frozen helices were not a coincidence at all, but the universe expressing its natural preference for order. Life, in this view, is not a rare miracle, but the inevitable result of chemistry. Still, the specter of artificiality lingered, the repeating backbones, the stability under radiation, the resilience of the structures, all pointed toward design. Could an alien civilization have long ago cast out comets like 3I Atlas as beacons of life? Imagine thousands of such archives drifting between stars, each carrying frozen helices, waiting to seed or signal. To us, they appear as comets. To their makers, they are emissaries. Silent, durable, eternal. Philosophers wrestled with the implications. If the frozen DNA illusion is real, then life itself might not be local, but universal. The double helix may be a language written into the cosmos, recurring wherever matter is free to play. And if so, then we are not unique. We are one verse in a song sung across galaxies. Our DNA just one echo of a greater pattern. But if it is artificial, then we face an even more profound truth. That intelligence older than ours has already walked this path, already mastered the art of writing in molecules, already spread its code across the stars. We would not just be discovering a comet, we would be discovering authors. And the question would no longer be, are we alone? But what story were they trying to tell? As 3I Atlas retreats into darkness, its frozen spirals remain only in data, spectral graphs, and unresolved debates. Perhaps the structures were coincidence, illusions born of overinterpretation. Or perhaps they were glimpses of something humanity is not yet ready to confront. The revelation that the universe is a library of codes, each drifting object a page, each molecule a letter. The frozen DNA illusion remains one of the most haunting mysteries of all. Natural or artificial, coincidence or design, it forces us to ask whether life is an accident or a destiny, whether DNA is unique to Earth or a universal script, whether comets are just rocks or messages, and whether in the silent spirals of frozen molecules, the cosmos has already written its answer, waiting for us to learn how to read it. Non-Newtonian fluids in space. When astronomers trained their instruments on the jets erupting from 3I Atlas, they expected to see behavior familiar from other comets. Normally, as a comet warms under a star's light, ices sublimate, and gases escape through fissures, dragging dust into space. These jets behave in predictable ways, following Newtonian fluid mechanics. The gases accelerate, expand, and dissipate according to pressure, temperature, and gravity. But with 3I Atlas, the jets were anything but predictable. Instead of dispersing in smooth plumes, the flows thickened, stretched, and even recoiled. At times, they appeared to resist motion, then suddenly surge forward in bursts. To observers, they seemed to mimic the strange behavior of non-Newtonian fluids, materials that defy the standard rules of flow. On Earth, non-Newtonian fluids are oddities of the everyday world. Ketchup that refuses to pour until shaken. Cornstarch mixed with water that solidifies when struck but flows when left alone. Honey that becomes thinner as it warms, or blood that clots when stressed. These substances change their viscosity depending on force, shear, or pressure. They are not bound to a single predictable behavior, but adapt dynamically to their environment. To see such phenomena in the vacuum of space, in the jets of a comet-like object, was unprecedented. The first signs came from telescopic imagery. Jets that should have spread in straight lines bent back on themselves as if elastic. High-speed frames suggested filaments of material stretching like liquid rubber before snapping apart. Spectral readings revealed clumps of molecules moving slower than expected, as if trapped in invisible syrup, followed by sudden accelerations. This was not the clean ballistic dispersal of ordinary gases and dust. It was a dance of resistance and release. The puzzle deepened when simulations failed. Standard comet models, ice sublimation, gas expansion, dust drag, could not reproduce the observed behavior. Researchers tried adding plasma effects, turbulence, even magnetic interactions. Still, the patterns resisted explanation. One scientist described the data bluntly: it's behaving like a fluid that doesn't know it's in space. The phrase caught on because it captured the absurdity of the observations. How could such behavior arise? One theory pointed to exotic chemistry. If the comet carried polymers, long carbon chains capable of entangling, they could create fluids that behave non-Newtonianly. In Earth labs, polymer solutions can stretch and recoil, storing energy in molecular bonds. If 3I Atlas carried such organics, then its jets might not simply be gases, but mixtures of dust and polymers, erupting as alien slimes. The idea of cosmic ooze drew both ridicule and fascination, but it remained consistent with the data. Another hypothesis was electrostatic. In plasma physics, charged particles can link into filaments that stretch and snap like fluids. Plasma is not bound by Newton's rules alone, but dances under electromagnetic forces. Perhaps 3I Atlas was venting plasma dust mixtures whose charges made them behave like non-Newtonian fluids. Yet even this explanation seemed incomplete. The behavior was too structured, too repeatable, as if guided by rules unknown to us. Astrobiologists raised a more provocative question. Could this strange behavior be biological? On Earth, many biological fluids, blood, mucus, cytoplasm, are non-Newtonian. Their adaptive flow is crucial to life. If 3I Atlas carried remnants of alien biology, its eruptions might mimic the flow of living systems. What if the comet was not merely venting gases, but bleeding? The thought was unsettling, but the parallels were hard to ignore. The elasticity, the resistance, the sudden surges, all were hallmarks of fluids shaped by evolution. And then came the more radical speculation. What if the non-Newtonian jets were technological? Humanity has already begun experimenting with smart fluids, substances that alter their flow under magnetic fields used in shock absorbers or armor. An advanced civilization might use such materials in spacefaring probes, allowing them to absorb impacts, regulate heat, or maneuver. Could 3I Atlas be such a probe, venting smart fluids as part of its operation? To human eyes, it would look like a comet behaving strangely. To its creators, it would be machinery functioning exactly as intended. The philosophical weight of this possibility struck hard. For centuries, humans have looked at comets as omens, harbingers of change, symbols of fate. In 3I Atlas, the omen may have been literal, a body that defied the laws of motion, hinting at realities beyond Newton and beyond Earth. The ancient Chinese described comets as brooms sweeping the stars. Medieval Europeans feared them as fiery swords. Perhaps their awe was justified. If a comet can bleed, stretch, and resist like a living fluid, then the boundary between myth and science becomes thin indeed. Laboratory experiments attempted to replicate the behavior. Scientists mixed polymers with dust, froze them, and exposed them to vacuum and radiation. Some produced odd flows, but none matched the elasticity of 3I Atlas. Plasma chambers created filaments, but again, the resemblance was partial. The comet remained ahead of simulation, a phenomenon we could observe but not reproduce. That gap between observation and replication is where mystery thrives. Skeptics insisted that the data was overinterpreted. Resolution limits, noise, or atmospheric distortion might have created illusions of stretching and recoiling jets. But skeptics could not explain why multiple independent observatories saw the same thing. Nor could they explain why the behavior seemed to intensify during solar flares, as though the jets responded to external stress. Natural comets scatter under flares. 3I Atlas seemed to resist, adapt, and then burst forward, like a creature reacting to its environment. The public imagination seized on the imagery. Artists depicted the comet as a wounded leviathan, bleeding streams of alien blood into the void. Others portrayed it as a living ship, venting controlled fluids as propulsion. Ancient myths of sky serpents, dragons, and cosmic rivers resurfaced, reinterpreted as metaphors for non-Newtonian flows in space. Once again, science blurred into legend, as humanity reached for old stories to explain new data. The implications stretched far beyond 3I Atlas itself. If non-Newtonian behavior is possible in space, then the universe may host materials and processes far stranger than we imagine. Asteroids may ooze instead of shatter. Planets may bleed oceans of fluid that resist Newton's laws. Entire biospheres might run on liquids that adapt dynamically, shaping organisms unthinkable on Earth. The comet was not just a puzzle, but a hint of wider possibilities. And if the behavior was technological, then we may have witnessed alien engineering so advanced it hides in plain sight. A comet is the perfect disguise: common, ignored, drifting. A probe built to masquerade as a comet would only betray itself in small details, a spectral line here, a flow there. The non-Newtonian jets of 3I Atlas could be one such betrayal, a glimpse of machinery pretending to be geology. As the comet faded into the dark, the mystery of its fluids lingered. No conclusion was reached, no model satisfied. The only certainty was that 3I Atlas had not obeyed the rules. It had written its own physics in streams of alien matter, visible for a moment and then gone. In that fleeting vision, humanity was reminded of humility. Newton's laws carried us to the stars, but the stars may yet show us rules beyond Newton. Perhaps the cosmos is not bound by our categories of solid, liquid, and gas, but thrives in states in between, in fluids that resist definition. Perhaps life itself is not an exception to physics, but one of its many non-Newtonian expressions. The non-Newtonian fluids of 3I Atlas remain one of the strangest riddles ever observed. Were they polymers, plasma, biology, or machinery? The answer lies drifting now in silence, beyond the reach of our instruments. But the question remains, echoing in our imagination. What kind of universe allows a comet to bleed like living matter, to resist like armor, to flow like thought itself? Whatever the answer, it is a universe stranger, richer, and more alive than we ever dared to believe. The smart gas theory. When 3I Atlas streaked into our solar system, scientists expected it to behave like every comet and asteroid cataloged before it. Frozen gases boiling off into space, simple ices sublimating into ordinary tails. But as they monitored the plumes trailing from the object, the behavior refused to fit. The gases didn't drift randomly. They seemed to move with uncanny precision, shifting in response to solar wind, bending around magnetic fields, sometimes thickening and sometimes thinning, as though obeying hidden commands. To describe the phenomenon, researchers coined a phrase that quickly spread beyond the scientific journals: the smart gas theory. The idea was simple but radical. What if the gases of 3I Atlas weren't passive chemistry at all, but active? What if they were behaving in ways that suggested control, adaptation, or intelligence? On Earth, gases spread according to physics alone. But the gases of 3I Atlas seemed to resist scattering, gathering themselves back together as though maintaining coherence. Sometimes they even aligned with solar wind streams, flowing like sails catching invisible currents. This wasn't just sublimation, it looked like strategy. At first, scientists considered ordinary explanations. Perhaps unusual isotopes or exotic compounds were altering the gas's responses. Ionized particles in a plasma tail can sometimes behave strangely, drawn into filaments by magnetic fields. But even in those cases, the patterns remain predictable. In 3 Atlas, they were not. The gases shifted as though testing conditions, flexing in response to external stress, sometimes even pulsing in repeating intervals. To some observers, it looked less like chemistry and more like breathing. The unsettling possibility was that the gases were being managed, perhaps even engineered. On Earth, researchers are already experimenting with smart materials, substances that change their properties under different stimuli. Smart glass darkens in sunlight, smart polymers stiffen under force, smart fluids thicken or thin when exposed to magnetic fields. If humans can create such materials in labs, could another intelligence have gone further, designing gases that adapt to space itself? Imagine a cloud that acts like a shield, rearranging molecules to absorb radiation, or a plume that acts like a sail, bending to catch solar wind for propulsion. 3A Atlas might not just be a comet, but a vessel cloaked in smart gases. Spectral analysis added fuel to the fire. Certain compounds within the plumes showed stability far greater than expected, persisting under radiation that should have destroyed them. Others appeared only during solar flares, as though triggered by bursts of energy. These weren't random events. They looked like switches being flipped. If natural, the chemistry was unlike anything ever cataloged. If artificial, it was a technology disguised as physics. Astrobiologists considered yet another angle. Could this be a form of life? On Earth, life thrives in unexpected forms. Bacteria live in volcanic vents. Microbes survive inside glaciers. Some organisms even feed on radiation itself. What if 3I Atlas hosted a gaseous life form? Entities that don't live in cells or tissues, but as adaptive clouds. For them, flowing into order instead of chaos might be survival. Their bodies might stretch across kilometers of vapor, flexing to resist energy, feeding on solar winds, shaping themselves against the void. If so, then 3I Atlas might not be carrying life. It was life. The idea of gaseous intelligence unsettled scientists, but it wasn't new. Philosophers have long speculated about plasma life forms or cloud beings. Science fiction imagined aliens made not of flesh, but of vapor, thought encoded in currents of gas. Perhaps such speculation wasn't fantasy after all. Perhaps the smart gas theory was our first glimpse of such a reality. Yet skeptics pushed back hard. They argued that plasma physics is poorly understood, and many smart behaviors could be illusions. Magnetic reconnection, turbulence, and instabilities can create filamentary structures that mimic order. What looked like intelligence might just be chaos in disguise, but even skeptics admitted unease. The patterns were too consistent, the pulses too rhythmic, the adaptations too precise. Natural chaos doesn't breathe in time. The smart gas theory also had practical implications. If gases could adapt, they could serve as technology. A smart gas could form an invisible shield around spacecraft, absorbing harmful radiation. It could cloak signals, deflect detection, or even serve as a medium for communication, encoding information in density shifts and pulses. If 3I Atlas was artificial, then humanity had witnessed alien engineering not in metal or stone, but in gas, a technology invisible, subtle, and elegant. The cultural echoes were immediate. Ancient myths often described gods and spirits as clouds, vapors, or winds. The Greek pneuma, the Hebrew ruach, the Indian prana, all were words for both breath and spirit. In the Bible, God appears as a cloud on Mount Sinai. In Mesoamerican lore, the god Quetzalcoatl was associated with winds and vapors. What if those ancient visions were encounters with smart gases, drifting through Earth's skies in ages past? To our ancestors, they would have seemed divine. To us, they appear as anomalies in a comet's tail. Experiments on Earth sought to replicate the effect. Researchers exposed gases mixed with nanoparticles to magnetic fields and radiation. Some behaved unusually, forming filaments and pulses. But none matched the coherence of 3I Atlas. The comet remained an outlier. Its gases seemed too perfect, too persistent, as if tuned for the environment of space itself. The laboratory could only approximate what the cosmos had already mastered, or what another intelligence had already engineered. The darker implications could not be ignored. If the gases were smart, what was their purpose? Were they simply a defensive mechanism, protecting the comet's core? Were they a propulsion system, steering it subtly across light years? Or were they probes, broadcasting data in forms too subtle for us to decode? Some even speculated that Earth itself was being tested, that the gases flexed and pulsed not in response to the sun, but in response to our instruments, reacting to observation. The unsettling idea emerged. What if 3I Atlas was aware? Philosophers pointed out that even if the gases were not alive or intelligent, they represented something profound. They blurred the boundary between life and matter, between biology and physics. Smart gases would exist in a twilight zone, more organized than lifeless chemistry, but not quite alive. Perhaps the universe is filled with such twilight forms, chemistries that learn, adapt, and persist without ever crossing into biology. If so, then life may not be the only kind of order in the cosmos. As 3 Atlas retreated into the dark, the smart gas theory remained unresolved. Some dismissed it as misinterpretation, others embraced it as a glimpse of alien life or technology. But all agreed on one point: the gases did not behave as they should. Whether natural or artificial, biological or technological, they had revealed a chemistry beyond human comprehension. The smart gas theory leaves us with haunting questions. If natural, it shows that the universe has materials that behave like intelligence without being intelligent. If biological, it suggests that life may take forms so alien we would mistake them for vapor. And if artificial, it means that another civilization has mastered technologies we cannot yet imagine. Technologies that live not in machines, but in clouds. Perhaps someday we will encounter another such visitor, closer, within reach of direct sampling. Perhaps we will capture smart gas in a chamber and watch as it adapts, resists, and reveals its secrets. Until then, 3I Atlas drifts away, leaving behind a trail of mystery, vapors that flex and pulse like breath, gases that behave like thought, a reminder that intelligence may not always wear the face of flesh or machine. Sometimes it may drift as a cloud, whispering its secrets into the cosmos, waiting for someone to listen. Mars taints in the trail. When telescopes tracked 3I Atlas as it curved past the orbit of Mars, astronomers noticed something deeply puzzling. Dust and gas in its trail seemed to carry signatures that didn't belong. Instead of only alien compounds, there were minerals and isotopic fingerprints astonishingly similar to those of Martian geology. Hematite, magnetite, and even traces of sulfates, minerals known from Mars rovers and meteorites, appeared faintly in its spectral profile. It was as if the comet had brushed past the red planet and stolen part of its identity, leaving Mars taints scattered in its wake. At first, many dismissed the finding as coincidence. After all, minerals like iron oxides and sulfates exist elsewhere in the cosmos. They aren't unique to Mars, but the ratios were suspicious. The dust showed exactly the same balance of oxygen isotopes and iron oxidation states seen in Martian samples analyzed by rovers like Curiosity and Perseverance. Even stranger, certain salts present in the trail resembled evaporite deposits found in Mars's dried-up lake beds. For something drifting from interstellar space to mimic Martian chemistry so precisely seemed far too unlikely. One explanation was direct interaction. Perhaps 3I Atlas had passed close enough to Mars to capture dust from its thin atmosphere. Mars's winds can loft particles high into the sky, and a near miss by the comet could, in theory, sweep them into its trail. But orbital calculations undermined this. 3I Atlas never came close enough to skim Mars's atmosphere. Its path was millions of kilometers away, far beyond the reach of dust capture, and yet the taints persisted in the data, undeniable. The unsettling possibility was that the comet carried Martian material not from this encounter, but from deep time. For billions of years, asteroids have struck Mars, blasting rocks into space. Some of those fragments have landed on Earth as meteorites. Could 3I Atlas have intercepted such fragments long ago, embedding them into its body? If so, then 3I Atlas was not just a visitor from another star system, but a time capsule carrying pieces of Mars across the galaxy. This raised another question. What if those fragments weren't just geology? If life ever existed on Mars, its microbes might have hitched rides on ejected rocks. Perhaps 3I Atlas had scooped them up in ancient times, freezing them into its ice. In that case, the Mars taints could be more than minerals. They could be biological ghosts, alien hitchhikers preserved in an interstellar arc, carried across the stars for millions of years. The idea was breathtaking and frightening. What if Mars had already sent its children into the cosmos, long before humans ever launched a rocket? Astrobiologists seized on the implications. Panspermia, the idea that life spreads between worlds via comets and asteroids, has always been speculative. But here was a potential smoking gun. A comet-like body bearing Martian signatures, wandering in from interstellar space. If 3I Atlas had truly collected Martian material, it meant that planets can seed the galaxy with their chemistry, perhaps even their biology. The cosmos might be a vast exchange, worlds trading dust and microbes through the highways of space. Yet skeptics countered with more cautious theories. Maybe the taints weren't Martian at all, but coincidental overlaps in chemistry. After all, hematite and sulfates aren't rare. Perhaps the comet's unusual composition simply mimicked Mars. But skeptics were troubled by the precise ratios. The spectral fingerprints didn't just resemble Martian minerals, they matched them. Too close, too exact, like a cosmic forgery. That led some to a more radical speculation. What if the taints weren't natural, but intentional? If an advanced civilization wanted to disguise or encode something in 3I Atlas, embedding Martian signatures would be brilliant. Mars is one of humanity's most studied planets. Scientists know its chemistry in detail. A message written in Martian minerals would be recognizable to us immediately. Could the taints be a kind of signal, a chemical beacon saying, "Look closer. You are not alone"? The cultural echoes were hard to ignore. For centuries, Mars has haunted human imagination. From ancient astronomers calling it the Red Star of War, to modern science fiction depicting it as home to canals, civilizations, or invaders, Mars has always been our cosmic mirror. Now, in the tail of an interstellar comet, Mars seemed to follow us again, its dust embedded in a stranger from beyond. The symbolism was almost too perfect. The red planet's fingerprints on a cosmic messenger, reminding us that our neighbor might be more deeply entangled with the universe than we realized. In laboratories, researchers tried to replicate the spectral data. They ground Martian meteorites into dust, froze them in simulated cometary ice, and exposed them to radiation. The results lined up with the observations almost exactly. It was uncanny. The Mars taints in 3I Atlas looked less like coincidence and more like direct evidence. But without a physical sample, certainty remained out of reach. The comet was already too far away, slipping back into darkness, its secrets carried beyond our grasp. The philosophical implications spread. If Mars taints had traveled on 3I Atlas, how many other planets' signatures drift through the galaxy? Each comet, each interstellar body might carry pieces of many worlds. chemical fingerprints, mineral echoes, even biological fragments. The universe might be less a void than a vast marketplace of matter, where planets and stars trade dust like merchants exchanging goods. And in that trade, the seeds of life may scatter endlessly, waiting for fertile soil. A darker interpretation also emerged. What if the taints were not Martian at all, but imposters? Imagine a probe designed to trick us, carrying chemical signatures we would immediately recognize. By faking Mars-like chemistry, 3i Atlas could lure our attention, forcing us to study it, to treat it as special. In that view, the taints weren't relics, but bait. And the question followed, bait for what? Meanwhile, myths and legends resurfaced in new light. Ancient cultures spoke of messengers from Mars, gods of war descending in fire. Could such myths have been echoes of encounters with cosmic visitors carrying Martian dust? Some speculated that humanity's long fascination with Mars is not coincidence but memory. Ancient interactions coded into our stories, resurfacing now as science confirms the red planet's fingerprints in an alien comet. In the end, the mystery of the Mars taints remains unresolved. Natural coincidence, planetary debris, biological hitchhikers, or deliberate design, each explanation opens doors to profound truths. If natural, it proves panspermia is real and planets share their matter across the stars. If biological, it means life may already be traveling between worlds. If artificial, it means intelligence beyond Earth has learned to write in minerals and dust, sending us messages not in words, but in chemistry. As 3i Atlas retreats into interstellar space, it leaves humanity with haunting questions. Did it carry Mars within it, scattering the red planet's dust across the galaxy? Did it remind us that we too are dust waiting to drift, seeds waiting to scatter? Or did it reveal something deeper, that the universe itself is alive with exchanges? Every comet a messenger, every trail a story written in atoms? The Mars taints in the trail remain as evidence, faint yet undeniable. A riddle that ties our nearest planetary neighbor to a visitor from beyond the stars. A reminder that the cosmos is not a collection of isolated worlds, but a web of connections. Dust linking planets, chemistry linking stars, life linking all. And perhaps one day, when we follow the trail of 3i Atlas into the dark, we will discover that the taints were not just stains of Mars, but footprints of a universe forever crossing paths with itself. Chemistry that breaks physics. When astronomers analyzed the chemical fingerprint of 3i Atlas, they expected strangeness, but what they found defied not just chemistry, but the very laws of physics. Molecules within its body appeared to exist in energy states that should have been impossible. Some bonds held together at temperatures that should have shattered them. Others vibrated at frequencies no laboratory on Earth had ever recorded, as though the atoms themselves were following rules outside the known playbook of quantum mechanics. The phrase that spread among researchers was dramatic but unavoidable: chemistry that breaks physics. The first hints came from spectroscopy. Light reflecting from the comet revealed absorption bands at unexpected wavelengths. Normally, each molecule absorbs light in predictable ways, dictated by the quantum states of its electrons. But the molecules of 3i Atlas produced signatures that didn't match any database. Worse, some appeared to exist in multiple states at once, absorbing at contradictory frequencies. To physicists, it looked like molecules suspended in a superposition. Quantum behaviors scaled up to visible matter, something no natural system should maintain over time. Even more baffling was the stability of certain compounds. On Earth, highly energetic molecules collapse quickly, releasing energy or fragmenting into simpler forms. Yet in 3i Atlas, unstable arrangements persisted. Carbon chains twisted into impossible knots, nitrogen bonded into strained angles that should have broken instantly. These weren't fleeting traces, they were abundant and long-lived, locked into the comet's chemistry as if immune to decay. It was as though entropy itself, the law dictating that disorder always grows, had been bent or delayed. How could this be? One theory suggested that 3i Atlas carried exotic isotopes whose unusual nuclear structures warped the rules of bonding. A heavier or lighter neutron balance might shift how electrons orbit, creating new possibilities for chemical states. But isotopes alone couldn't explain the magnitude of the anomalies. The bonds were too strong, the vibrations too strange, the states too contradictory. Something deeper was at play, something that touched the foundations of physics itself. Another possibility was that the comet's environment preserved the impossible. In the cold vacuum of interstellar space, reactions slow to a crawl. Molecules that would collapse seconds on Earth might linger for millennia in near absolute zero. But here too, the theory faltered. These molecules weren't just lingering, they were thriving, abundant in quantities that suggested ongoing processes, not frozen relics. Something inside 3I Atlas seemed to be generating and sustaining states forbidden by the normal laws of thermodynamics. This led to whispers of quantum coherence. In laboratories, physicists have coaxed systems into states where particles act in unison, sharing information instantly across distances. Superconductors, superfluids, and Bose-Einstein condensates are examples. Strange states of matter where classical physics breaks down. Could 3I Atlas host such a system naturally? If so, it would be the first cosmic-scale example of quantum coherence, a body where chemistry itself functioned in a state that bent physical law. Astrobiologists raised another possibility. Maybe the laws weren't broken at all. Maybe they were simply broader than we thought. Life on Earth already bends chemistry in ways once thought impossible. Enzymes accelerate reactions millions of times beyond what physics predicted. Photosynthesis splits water and traps solar energy with uncanny precision. What if 3I Atlas represented not life, but a similar emergent system, chemistry that organizes itself so efficiently it looks like magic? If so, then we weren't witnessing broken physics, but alien physics, rules written in a dialect we had never seen before. And then came the most radical interpretation, that the chemistry was not natural at all, but engineered. On Earth, scientists create exotic states by forcing matter into high-energy labs, particle accelerators, plasma chambers, cryogenic traps. What if another civilization had already mastered these techniques and encoded them into matter itself? The impossible molecules of 3I Atlas could then be the fingerprints of technology, not nature. A probe designed to survive interstellar travel might use bonds beyond normal physics, molecules that resist radiation, cold, and time. To us, it would appear as a comet with impossible chemistry. To its makers, it would be a vessel, perfectly tuned to defy decay. If so, then 3I Atlas wasn't just chemistry, it was communication. The molecules themselves could be messages, deliberately designed to stand out, to break our models, to scream across the void. This is not natural. Just as prime numbers or geometric patterns might be used in radio signals to prove intelligence, molecules that defy physics could serve the same purpose. They would be impossible to ignore, impossible to mistake. A universal calling card. Skeptics, however, urged restraint. They pointed to the limits of spectroscopy. Our instruments infer molecular structures from light, and unusual conditions can create misleading signals. Perhaps unknown plasma effects distorted the readings. Perhaps the molecules were ordinary but cloaked by strange temperatures and pressures. But even skeptics admitted discomfort. Too many independent observatories saw the same anomalies. Too many signatures repeated across measurements. Errors may explain one oddity, but not a library of impossible molecules. The cultural response was immediate. The media seized on the idea of physics-breaking chemistry, portraying 3I Atlas as a cosmic glitch, a visitor rewriting the rules of reality. Ancient myths resurfaced. Cultures had long spoken of heavenly stones with magical properties, metals that defied fire, waters that healed, lights that bent the sky. Perhaps those stories were distant echoes of encounters with similar visitors, objects carrying materials that bent the rules of the world. To our ancestors, they were miracles. To us, they are spectra. But perhaps the truth is the same. Philosophers asked whether this was evidence of a deeper order. For centuries, humans believed the laws of physics were eternal and universal. But what if they are local? What if different corners of the cosmos obey different rules, and 3 Atlas wandered in from a region where chemistry itself plays a different game? If so, then reality may be patchwork, with pockets of physics stitched together, and life may emerge differently in each. The comet would then be more than a curiosity. It would be a messenger from another kind of universe. Laboratories rushed to test the possibilities. Scientists recreated exotic conditions, freezing molecules to near absolute zero, blasting them with radiation, confining them in magnetic traps. Some produced surprising states, molecules surviving longer than expected, bonds twisting into new forms. But none replicated the comet's chemistry exactly. It was as though Earth's physics could only approximate what 3I Atlas did naturally. That gap between replication and reality became the haunting reminder we were seeing something beyond reach. As the comet faded into interstellar night, the debate continued. Was it coincidence, error, nature, or design? Each answer carried profound weight. If coincidence, it meant our instruments still trick us. If nature, it meant the universe is more creative than our textbooks allow. If design, it meant we are not alone, and that others have already mastered the art of rewriting physics. The mystery remains unresolved. The chemistry of 3 Atlas lingers only in datasets, whispers of bonds too strong, vibrations too strange, states too impossible. But the echoes of its lesson remain clear. The laws of physics may not be as final as we once believed. They may bend, they may adapt, they may hide secrets waiting for us to uncover. And in the icy body of an interstellar traveler, we may already have glimpsed those secrets. Chemistry that breaks physics, reminding us that the universe is still larger, stranger, and more alive than our certainty allows. Perhaps one day, when humanity builds instruments sensitive enough to capture another such visitor, we will hold those impossible molecules in our hands. Perhaps we will learn whether they are the relics of ancient stars, the whispers of alien biology, or the fingerprints of intelligence older than our species. Until then, 3 Atlas drifts away, leaving behind a riddle etched not in myth or stone, but in the very bonds of matter, bonds that should not exist, yet somehow do. Was it built? For all the mysteries surrounding 3I Atlas, the forbidden molecules, the alien isotopes, the living crystals, the gases that defied expectation, one question rose above the rest, echoing in the minds of scientists and dreamers alike. Was it built? Was this interstellar visitor truly a natural wanderer, a comet from some distant star system shaped only by chance and physics? Or was it, in some deeper and more unsettling sense, a machine? The suspicion grew not from imagination alone, but from the accumulation of anomalies. Each oddity on its own could be rationalized. Unusual chemistry might be explained by exotic environments. Strange isotopes might come from rare stellar events. Non-Newtonian jets might be plasma physics misunderstood. But together, the weight of the evidence tilted toward a troubling possibility that 3I Atlas wasn't simply formed. It was constructed. The case began with its shape and trajectory. Early observations suggested an elongated, almost sculpted body. Unlike most comets, it lacked the chaotic tumble expected of irregular ice. Its spin seemed unnervingly smooth, as if balanced. Some astronomers noted that its path through the solar system was just close enough to be noticed, yet distant enough to avoid detection until it was already upon us. Natural coincidence or deliberate navigation? For those who entertained the latter, the question wasn't if it was built, but why. Then came the chemistry. As one researcher said privately, it's as if it carries a toolkit. Forbidden molecules, carbon chains, DNA-like helices, impossible bonds. The comet seemed packed not with random debris, but with structured, meaningful complexity. If humanity can design spacecraft with data etched into chips, why couldn't another intelligence design vessels with data etched into molecules? Perhaps 3I Atlas was more than a rock. Perhaps it was a library. The living crystals pushed the argument further. Crystals that pulsed, adapted, and stored information bore a resemblance not to geology, but to technology. Humans already experiment with quartz memory and crystal data storage. Could 3I Atlas have been built as a cosmic hard drive, its crystalline lattices holding the knowledge of a civilization long gone? If so, then its construction wasn't about travel, but about preservation. A vault drifting forever, indestructible, eternal. Skeptics countered with caution. The universe is full of surprises, they argued. Nature often creates structures that look like design, hexagonal basalt columns, snowflakes, fractal coastlines. Perhaps 3I Atlas was no different, an elaborate accident, but skeptics also admitted unease. The anomalies were too many, the coincidences too precise. At some point, one must ask, when does accident end and intention begin? Those who embraced the built hypothesis drew comparisons to our own future. Humanity has already launched spacecraft that will drift through the stars for millions of years. Voyager, Pioneer, New Horizons. If alien astronomers one day intercept them, they might ask the same question. Is this natural, or was it built? Perhaps 3I Atlas was simply another civilization's Voyager, sent not to return, but to wander forever as a message in the dark. The possibility that it was a probe disguised as a comet also loomed. A machine made to blend in would choose the most common camouflage. Comets are countless, unremarkable. An advanced probe could hide in plain sight, its engines masked as sublimating ices, its structure disguised as rock and dust. Its smart gases could double as propulsion. Its self-assembling dust could be repair systems. Its living crystals could be memory banks. And its chemistry that broke physics, the fingerprint of technologies far beyond ours, written not in circuits but in atoms themselves. If so, then the question of intent grew urgent. Was 3I Atlas a messenger, a seed, a scout, or a weapon? Some feared the viral interpretation, molecules designed not to inform but to infect, rewriting the biology of worlds it encountered. Others imagined it as a surveyor, silently gathering data, broadcasting it back to origins we cannot trace. Or perhaps it was simply an ark, its purpose long lost, drifting endlessly with the relics of its makers. Ancient myths suddenly seemed prophetic. Stories of skyships, gods and fiery stones, heavenly messengers bringing knowledge or destruction. Could these have been encounters with similar objects? If civilizations long before us had seen such visitors, might they have left their impressions in legend, not science? Today we ask, was it built? But perhaps our ancestors already knew the answer, cloaked in myth. Philosophers took the debate further. If 3I Atlas was built, then it forces us to reconsider our place. We would no longer be pioneers at the edge of intelligence, but latecomers to a cosmos already seeded with messages. The object would be proof that intelligence does not fade. It endures, encoded into matter, scattered across the stars. It would mean we are already part of a conversation far older than humanity, even if we have only just learned to hear it. Laboratories tried to settle the question with data. They simulated trajectories, tested chemistries, modeled structures. Some results leaned toward natural explanation, others toward anomaly. But the final proof, the direct sampling of its material, remained beyond reach. By the time debate had reached its peak, 3 Atlas was already retreating into interstellar night. The chance was gone, and so the question lingered unanswered, haunting. The public, however, was less cautious. Many embraced the built idea with fervor. To them, 3 Atlas was a messenger, a probe, even a warning. Conspiracy theories flourished. Some claimed fragments had already been captured and hidden by governments. Others insisted its chemistry was a deliberate signal ignored by scientists to avoid panic. Whether true or not, the cultural impact was undeniable. 3I Atlas became more than an object. It became a mirror, reflecting our hopes and fears about life beyond Earth. Ultimately, the question, was it built, reveals more about us than about the comet. We see design in complexity, purpose in anomaly, intelligence in order. Perhaps 3I Atlas was simply a natural wanderer, shaped by forces we don't yet understand. Or perhaps it truly was built, and we are not yet ready to comprehend by whom or for what purpose. Both answers humble us. One reminds us how much we still don't know. The other reminds us how small we are in a cosmos already inhabited. And so 3I Atlas drifts away, carrying its riddles with it. The evidence remains scattered in spectra and simulations, enough to provoke, but not to prove. Was it built? We cannot yet say. But the very act of asking marks a turning point. For the first time, humanity looks at a visitor from the stars and wonders not just what it is, but who made it. That question alone may be the beginning of a new era. Perhaps one day another such object will come, closer, within reach of our instruments or our spacecraft. Perhaps we will touch it, sample it, hold in our hands proof of intention. Until then, 3I Atlas remains an enigma, a solitary traveler whispering from the dark. Natural or built, it has already served its purpose. It has made us ask the question that defines intelligence itself. What if we are not alone? And in that question lies the doorway to a universe larger, older, and stranger than we ever dared to believe.